My name is Jason Green. I'm the Chief Technology Officer at Element Critical, a co-location services company throughout the United States. So without any additional fanfare, we're going to jump into this. And I will not take credit for the fact that the slide deck looks good. We hired somebody to make me look good because I couldn't do that on my own. So we're going to focus on the fact that edge is what we've heard it to be. Fundamentally, this is supposed to be where we're going to distribute all of our computing coming forth. And if you hear all the mythology out there, everything that you know and love today is going to change tomorrow. That we know that's not going to happen. But we'll talk about what that could actually look like. So just giving us an overview, and I think contents are good. What we want to talk about is the background of how we got here. We're going to talk about things that we know and we're aware of. We're going to talk about the interrelationships of the cloud and the edge and how all these things tie together, because that's kind of important. Dreaded word, ecosystem. I've got my own buzzwords. And then, like any other new fad, you've got people that have dove in. They're wearing edge underwear. Everything is edge all day. Look at me, I love the edge. The edge is the greatest thing ever. And then you've got the people who are like, there is no edge. The earth is flat. We're not going to fall off because that's not an edge. We're going to talk about those folks and why some of that's important and why some of it isn't and where the FUD comes from. And then finally, we're going to get to how all this actually happens, because there's got to be infrastructure and someone has to support it. So we're going to dive into that as well. So let's start off with the technology challenge. And I want to dive into some of the things that we're aware of. Now, you'll like this since you asked about N microphones. We're N+5 on the clicks when we get to these slides because we did something wrong. So I want to get into perceived human issues. And I think this is incredibly important because we're going to pick on everybody here, especially those of you that are on your phones, because you can't help yourself. And I titled this First World Problems because I think everybody in here doesn't have any third world problems. You all have first world problems. That's what we have. And we're going to talk about this guy. We see this guy. I flew in with him. And it's awesome because it's like me, 2 phones, 95 different devices, and he's that important. And we're going to go through what some of these things are that need to be identified. So we're going to lay out some concerns. So what are your concerns in a first world issue? Availability is critical. I couldn't get to Facebook, and oh good Lord, no one got to see what I could do over the weekend, and now I'm mad. So my favorite thing is, like, I'll be in New York and you're on the subway and you'll see someone tapping their phone, like furiously banging on their phone. And I like to ask people, like, you know, I've got a colleague in here who claims he has Tourette's. He may be spreading things out later. But I ask and say, hey, you know, are you okay? You're tapping really hard. It won't load. Are you okay? And they're mad. So I find it amusing that the free service that they don't pay for that allows them to narcissistically post everything that they want to the world doesn't work, and they're pissed off. I don't get that. Well, that's a first world problem. I like this one. You'll hear people like, or you'll read it on the news. I was following this GPS thing and it took me to a place I wasn't supposed to go, and now I got in trouble. I mean, didn't you arbitrarily see that you drove into the ocean? It was blue. Like, you weren't paying attention? Yeah, but I punched in the latest Chinese restaurant that I wanted to go eat at and I ended up in the ocean. I mean, seriously, you didn't process blue? Blue meant ocean? Well, that seems to be a problem too. Load times. You know, things aren't happening fast enough. I'm waiting, give me what I want. So there's a summation to all this that we'll get to. I enjoy the data buffering piece. You know, you can actually see these people. I sat next to one of these guys on a plane. So he had his headphones on, and you watched it, and he kept kind of looking, and he's looking at his phone, and whatever song he was listening to was skipping forward because whatever service he had wasn't working right, and he was like getting agitated. He was visibly agitated, and I actually asked him later, I was like, what are you listening to? And he said kind of sheepishly, he's like, well, I listen to Guns N' Roses. He's like, oh, I'm going to use you in my slide deck. So apparently his whole effort there failed, so he didn't get any of that. And then you can read between the lines on this one. If I can't be irreverent, then I got a problem. And I only had 1 minute of myself today, and the 30 seconds that I really needed to get something done didn't happen. So the speed wasn't there. I'm waiting, and I've pixelated, and I only had 1 minute and 30 seconds. Now I got issues. What this really boils back down to is that we now have an expectant society that everything's supposed to happen really, really fast. It's supposed to happen as fast as I can get it. It's supposed to be optimal in its performance. And here's the best part. It's supposed to be free. I mean, that's utterly ridiculous, but those are our expectations, right? And we all know that. You know, you hear people, you know, Netflix isn't loading as well in my house. Seriously? That's the major problem that you have. Well, those are our expectations. If we transform that to what the real issues are here, and this is where this becomes incredibly important and germane, this is interesting. You talk about GPS accuracy. is there's a study that MIT proved where they were able to actually take a 3D printed turtle and put a couple of dots on it, and they tricked a drone into thinking that it was actually a tank. That's probably a problem. And that has an infrastructure issue. That's not actually what you're thinking that there's a programmatic issue. It's how that information gets transmitted to those devices in a timely manner so it actually functions. Availability. We talk about our military and all of the critical resources that happen to make that function properly. Well, if we're trying to send coordinates to a team that has a mission critical operation, they don't get them in time and we miss the person that we're supposed to attack, that's probably bad. And that's an infrastructure issue. You go back to load times. So you have a doctor, and the doctor is critically waiting on a patient that has to come in. I was a former EMT. You work in hospitals. You be around. Every second matters. If I've got to look at images and I can't get the image in enough quality or fast enough, somebody dies. And those are real critical concerns. And I think everybody here, regardless of your background, has some interaction with the medical community, and how much infrastructure is required to make that work. It's not simple. You take data buffering issues. Video's got to be real time. I was reading this article recently, and because of this keynote, I actually got to read things for a change instead of just the stuff I'm focused on, which is, this is great. And I'm looking at the discussion about video, and somebody's trying to make the argument that, well, what we're going to do is we're going to take all the real-time video and we're going to only upload the things to the cloud that are actually important. What defines important? If you've got to scroll through a whole series of video hours to define what's there, and it buffered so you missed the part where the guy actually robbed the person that you're trying to capture, well, that kind of defeated the purpose, so that doesn't work either. And then the speed. Fundamentally, you talk about financial markets, they spend gazillions of dollars to make sure their networks work right. If it's not fast enough and you miss a trade and somebody loses money, then there's issues. So these things all boil back down to, we've got the first world problems that all of us have where our convenience is interrupted. And then we have the real world problems of all the stuff that doesn't function that makes our lives really challenging. What does that boil back down to? And it fundamentally hits us into the infrastructure and where this comes from. So let's give a little background as to how we get here in this world that all of this is so eminently important. So where did we start? And I think this is where we critically get to, and we'll run through this quickly because I think everybody's aware of this. We started really big and in one place, right? Mainframes, big, solid, consistent infrastructure that was just dedicated to a location. Personal computers started giving us some distribution. And then we ended up with certain storage devices that allowed us to put things in different places where we could access them where we needed them to be. We then end up with compute that's in a smaller space, a smaller format. That's going to be a theme here. How do I shrink this down and get more in a different space? We ended up with a lot more computing power in a big infrastructure. So we went from small to then big, but then concentrated. So these are the variations of our systems. We then get into converged, where we take computing and network and storage and cram it all in the same place. So these all have applications in terms of how this functions. And then we get, where do we go from here? One of the things that the guy who was helping me put all this together said, I just want big pictures. So this is simple. We have phones. The evolution is now, where are we? What you have in your phone, if you think about it, was more powerful than any computer you've ever had in your life 3 years ago. And it's going to continue that these levels of devices require more and more. It also is what allows you to not really do work when you're sitting in your meeting and you're surfing whatever you happen to be doing and not paying attention. So multitasking is great, but the reality is the compute power is all now as mobile or as accessible as you can imagine, but it also has a lot of reference. Real-time everything. Goes to what we talked about earlier, right? I expect it now. I expect it the way that I want it. I expect it in a way that's going to be perfect for me every single time. And here's the best part. I don't really care whose job it is to make that work. That's your fault. Fundamentally, right? You think about our level of impatience. It used to be your biggest level of impatience was having to call Dell's help desk and getting a guy who would tell you that his name is Dave when you know that he's calling from Bangalore, and all he can keep telling you to do is reboot your machine. That was a certain level of impatience. Now you're just legitimately ticked off that your free application doesn't work right. And thematically, that is very important. We want everything right now. Well, now add the next level. So I think it's kind of funny. You see people walking around, how many steps did you take today? And now, not only how many steps did you take, people are tied into people that they don't even know and competing about who takes more steps than they do. Like, we are just contriving all kinds of ridiculousness. I think that's fantastic. So when you think about what it takes to make that work, this is what becomes important. Fitbit as a company isn't solely constrained to all of the things that they need to make their product work. They need a lot of other interactions with other services, other companies. You think about what your iWatch or whatever your wearable is, that actually ties into more things than you could ever imagine. But here's the only thing you know, and this is now the new thing. It used to be I had to look at my phone. I love you're in a conversation and somebody just does this. Like, damn, I mean, I know I was boring and all, but seriously? Like, oh no, it's good, I'm back again. Or you get this one where they do this, and then they gotta go look at their phone, and then maybe there's another phone, and then right when you think you could start your conversation again, they do this. So this is now indicative of all these different types of things that make that feasible. I guess maybe in a way that's great. I'm not really too excited about it, but what it does mean is that there's a huge reference behind this. How does that even happen? Why is that feasible? So we've got our, and again, think about the extrapolation. The real-time everything used to be that, well, supposedly now I can order a pizza online, that's pretty cool. Then I can have a phone that allows me to look up things, that's great, because, you know, not knocking Google, but I think almost all of us use Google exclusively for one thing, and that's to look up mundane things we didn't know about previously. You know, we're in an argument with our buddy about who sang in what band or played what position or what sport at what time. Google. And I got to have it right now because otherwise I'm going to lose my thought process. This is just going to continue to go, is that everything has to be now. And so we're seeing what is our version of this today. Just think about what the extensions are. And you've seen all the predictive movies before, into 2001 and 2010 are coming. So getting us to our next step is what is the background behind this? And I called it clarity blurred. It's because everybody here knows what cloud is, but doesn't know what cloud is. And I'm not knocking everybody. I mean, you know, we hear what cloud is, but cloud is a lot of different things. So when we throw these words out there, they're not just casual, there's a real level of importance to them. So if you hear the term hyperscale, we'll just distill it and make it really easy. These are massive data centers that the largest companies in the world that provide these services use to concentrate all their infrastructure. If you've never been in one, they're insane. It's huge, you can't even quantify it. Take a building as big as this entire building and shove computer equipment into it, and that's where all this processing power is existing. Is that the edge? Is that the cloud? Is it, well, it's all of the above. But when we talk about hyperscale and cloud, this is the facilitation for all this to actually function. So you think about all the data that's being generated. Your Fitbit is not just how many steps you took. It's where you are. It's where you took those steps. It's what else was going on around you while you were taking those steps. We'll talk about like Alexa and Siri and Google in your house and what that means later. This is all a collection of information. Well, where does it go? Because talking to somebody before we started today, I don't know about you guys, you hear the world is so small. Well, my litmus test is usually when I'm landing in at an airport and you see all the cars parked at that airport. All of a sudden you realize there's a whole hell of a lot more people here than you ever thought. Now imagine how much data you create on a regular basis. It's like the anecdotes are important. I don't know if you hear these statistics. The average human in the United States uses 80 gallons of water a day. I actually don't know how that's humanly possible, but that's apparently a statistic. Well, if you use 80 gallons of water a day, now imagine how much data you generate. Just you. Everything you touch, everything you do, everything that is an interaction with anything creates data. Well, where does it go? It has to go somewhere. So hyperscale and cloud. Colocation facilities service a different market. So they may have some of those cloud capabilities, but they're not typically in some large place that's off in the distance somewhere where you see these large buildings. They may be more close to a major metropolitan area. They have a different service orientation. They may be able to service people a little bit easier than you would if you were way out in the middle of nowhere. And there are data centers, massive ones, in the middle of nowhere. So that becomes the next tier in this. Local data centers give you then yet a closer approximation to the user base or to the actual company base itself. You can see we're getting closer to a certain population. They may not be as large, they may not have the same level of service, but their destination, if you will, is a closer proximity to something. Whether it's business, whether it's people, it's something that's going to get you closer to the use case. The edge is what this whole discussion is supposed to be. Well, what's the edge? Theoretically, the edge is supposed to be the closest I can get to the use case. Who's using it? Well, there's still one more step, and that's what we're calling micronodes, which is literally on top of service. So we'll take one step back real fast. If the edge is everybody that's using something, and I have to be as close as I can to the people that are actually using that, what does that actually mean? Well, it's not just people. So statistic 2015, for the first time in the history of the world, there was more non-human to non-human interaction than there was human to human. So it used to be you phone called or you talked to a human or you texted to a human. That's gone now. It's now all these devices are talking to each other. So the concept of edge is how do I facilitate the greatest amount of speed and service between devices and people? And the only way I can do that is to get rid of the things that cause me challenges. Data buffering, loss, and whatnot. That's latency. So I can sit there and scream all I want and no one in Massachusetts is going to hear me from here. And I'm loud. They can't hear me. There's a distance limitation. There's a distance limitation to your networks. We all know that. You hear about latency all the time. It has a downward pressure on how we're able to apply these services. So getting us closer to where we use these things is of paramount importance. So we're going to bring this back up and we're going to add some pieces to this. So just so you have some things to review, some bullets and whatnot, and I won't read them to you, but this will give you a perspective and a reference as to hyperscale and cloud and what that represents, what it's storing and where it is. Co-location, and again, getting a little bit closer, but just some differentiation. The local data centers and what they look like. How edge is appeared, and we'll show that a little bit later and give you some examples. And then finally, a micronode, which can literally be, and these become the true believers, it can be this small device that's supposed to take over the world. So something as big as this can be sitting in the middle of major metro Atlanta, and that's supposedly going to provide all the transmission we ever needed to make your Fitbit work better. I doubt that, but that's theoretically that could be the case. We got to mention commodity because one of the things that comes about with the concept of edge is, you know what, we're going to create a monolith and we're just going to slap it in there and everything's going to be consistent and it's going to be a great solution. By a raise of hands, how many people have been in a data center? Anybody in here? Everybody's been in a data center. Do they all look the same? Every data center looks the same, right? They all look exactly the same. They don't look anything alike. Every IT distribution looks the same, right? Because they all go to Dell, they buy the same, no they don't. Some of them go to HP. They all buy the same no, they don't buy the same network stuff. No one buys the same stuff because everybody's application is different. So the concept that the edge is going to be this consistent distribution across all these ways and means is an abject fallacy. I was a little disappointed, I guess, because of copyright rules. I couldn't use my picture of Madagascar. So I wanted all the zebras and the one zebra that, you know, it would have been good to have Chris Rock actually speaking as if he was the zebra that's not the zebra. But this is along those lines. So the apps don't look the same. They don't function the same. Even things that are developed on the same platform don't have the same requirements. So you think about this. Is Google Maps, does it work the same as Apple Maps? No. Do they have the same back-end infrastructure? No. Do they have the same requirements for the business? No. So if they don't have any of those same things, then how would they be supported the same way? So we have to start thinking about how do you manage an infrastructure that is changing, that has different requirements depending upon who's using it, what business is purveying it, wherever it comes from. I wanted to use the example of Microsoft because this leads us into, if certain people are thinking about certain things, certain companies, that's got to have a reference to the rest of us. Well, these are going to be large-scale topics. So I pulled this literally off of their site. They have a whole portion of the Microsoft website that's dedicated to Edge. Now, I don't know if you guys are aware, Microsoft is building some of the largest and most massive data centers in the world, and it's unrelenting. So they just went and stated that they permitted, I don't know, 300 megawatts of generators in Quincy, Washington. They're doing another massive project in Virginia. They can't keep up. Their requirements are just unconceivable. But on their website, they're talking about the variations of edge, and they're talking about intelligence and what the intelligent edge and cloud, and we don't have to read any of this stuff. But the focus here was if they're building these massive data centers, but they've also got a downward reference into the edge, what does that actually look like? And I mentioned the buzzword bingo because it's easy for a big company just to use all those words that we've already heard before and just throw them out there like cloud. Everybody want the cloud? I don't even know what that means. No, I need the cloud. Anybody need, and we have clients that'll call us, they'll go, we really need the cloud. I have no idea what you're talking about. Did you actually want to acquire the cloud? Yes, we would like to acquire the cloud. That's fantastic. You're not going to acquire the cloud. Which cloud would you like to buy? And I actually enjoy having these conversations because, I mean, they know that they're being messed with, but it's insane. The buzzword bingo, though, has some relatability. So for these guys, they have hyperscale all day. They're building massive data centers. That's their hyperscale back end. But they also do regional data center deployments because they have to be close. It's a requirement. They can't just distribute everything from wherever this central location is because you have loss. I'm guessing, how many people in here, so Office 365, probably everybody in here is using it. You run into those instances where you're like, I can't find that email. Well, you can't find that email because you and 4 billion other people are trying to access the same infrastructure. It's not scaled out yet. It's not that that's their fault. It's just not perfect because there's a lot of infrastructure that needs to support your request. Now, you're pissed off because you didn't get it in time, and you're actually paying for that, so you should be angry. But it's not there. They don't have the infrastructure yet. They're still building that out. So then that gets them to near edge. So they've actually got to have a series of deployments to be able to support this monolith that is Microsoft. Because all of their applications, everything that they do, all of this service has a scale to it. This also applies to us. And if we're going to talk about what do the data centers look like, they look like each of these things. I enjoy the part about the naysayers. So there's a whole group of people that are going to tell you right now that data centers are going to go away. They're gone. So there will be no more data centers, and everything's going to be edge. So if you haven't seen an edge distribution deployment, you'll hear a lot of buzz about, well, if we have a cell tower, and a cell tower actually must be network distribution, so therefore data is passing by there. So what I should do is I should build a data center right at the cell tower. That's awesome. You probably need to do that, but I'd like to see you build that same data center at the base of a cell tower in Metro Manhattan. That's probably not going to work. I mean, just think about that. Just think of all the ramifications of somebody that's actually now choosing to snuggle up and sleep next to your data center, or a dog that decides that your data center is where it's going to actually go do its business. These are all bad ideas, but we've got to figure out how to do the distribution. So the concept that the edge is now everything. We're going to push all of our compute, we're going to push all of our infrastructure right to where all the people live. Let's talk about scale now. We talked about how much data every single one of you generate. Where do we possibly store it if we're going to store it right where all of the people actually live? There's no way that that's humanly feasible. So like anything else, one of the things we wanted to debunk, and when we talked about, collectively, there was a bunch of us that talked about what this could be, it was to say that this is not everything. This is not nothing. It's a combination of things. But there are folks, and there's plenty of articles that you'll read that will tell you that all the compute in the world is now going to be driven into something that's this big, and we don't need data centers anymore, and we'll be able to manage that. I don't think that we can believe that. I enjoyed trying to find the blob. So the blob took over everything at some point. My mom would be really excited because she thought these movies were cool. I didn't, but I like the concept of the blob. And so I bulleted all these things out. One of the other reasons why the edge can't be everything is, how many of you are familiar with, and I already know the answer, how many have heard of AI? Everybody's heard of AI. How many have seen an AI deployment? An actual computer infrastructure AI deployment. If you haven't seen one, it's a lot of computers. It's a lot of horsepower. This is a lot of churn. It's a lot of physical power. Well, if I'm going to put that in a really tall, tiny data center somewhere, I can't get the compute that I need. So then you'd say, hey, I bought the cloud, because we're going to go back to that guy. I bought the cloud. I'm going to put my AI all in the cloud. You can't do that because it's expensive. You can put some of it in the cloud, but not all of it in the cloud. So one of the reasons that the edge can't be all of these things is it doesn't service every use case. Nothing is going to be that monolithic. It may be at some point, maybe, but it's doubtful. So for all of these reasons, we need relationship between how do we get close to people, and then how do we actually pull ourselves back and still be able to manage the cost? Because what was one of the premises that we said at the beginning? We want it fast, we want it great, and we want it cheap. Cheap equals free. And I think all of us are involved in some company selling some product somewhere. What's our biggest problem? It's commoditized, right? I mean, we own a co-location company. The first thing everybody says to us when they come in is, what's your price per kW? Well, isn't it more than that? Nope, I want it cheap. Okay, but what if my data center is better than his data center? I don't care. So the question about N earlier is fantastic. You start asking these questions about what's really important to you. Well, we've been cultured to believe that we want it cheap. Well, if I say that the edge is the purveyor of all of these things, it can't be cheap by definition. And we'll talk some more about that as we go. But this is why this has to be blended. I said there was a slide on Jell-O, so I was excited to do a slide on Jell-O. If you've seen Cloudy with a Chance of Meatballs, at some point when the food clouds are taking over and spitting things like cheeseburgers and hot dogs all in this town, there's this also, I thought it was fantastic, God bless you, where we end up with a massive Jell-O edifice in the middle of nowhere. And for some reason that just struck me as looking like a hyperscale data center. So I don't know. So, see, Cloudy with a Chance of hyperscale data centers. So if you remember the scene, there's this great scene where he dives into this and everything's made out of Jell-O. Well, the reality is this is not the flip side. The flip side is that the world is not going to become exclusively hyperscale data centers by definition. So I was reading that some data scientists were making the statement of, well, as networks get faster, we can build data centers further remote and we're not going to have to deal with latency. Clearly, they never took physics classes. So there's still going to be a distance limitation. You can't help yourself. At some point, you actually have to manage the data gets transferred back and forth. So we can say that the edge is going to take over everything. We debunked that. We then have to referentially debunk the concept that these massive monolithic data centers also take over everything. They may help make things more regionalized, but they can't be everything because by definition, you have to be close to the people. You have to be close to the users. You have to be close to the other applications. You have to be close to the devices. So last time I checked, being able to go and acquire 300 megawatts of power and 30 acres in the middle of Metro New York is probably not going to happen. So I've got to create a marriage here of relationship of how do I do this effectively at scale? So since this is about data centers, let's revolve that back for a minute. Any of you that are involved in architecture, design, construction, and whatnot know that the cost to build data centers has declined significantly as we've gotten better. We've gotten better, faster, stronger, cheaper. We've been able to improve that. We've been able to improve our timelines to deliver. That's all fantastic. But it doesn't actually take away some of the core requirements. So when we go buy data centers, one of the first things that we look at, well, where's the power? How much does it cost to get? So we'll translate for a minute, because this is kind of cool, at least watching these people running a little bit of a hamster wheel. Everybody's heard of cryptocurrency. Everybody. Everybody's heard of Bitcoin. Everybody's seen all that. About 9 months ago, when it was at its heyday, anybody here that had any involvement in data centers was probably fielding 7 to 10 phone calls a week that went like this. How much power do you have? I've got a couple of megawatts. Do you have more? I can get more. How fast can you get it? What do you need it for? We're mining. Okay. How much do you need? I need 100 megawatts. And you'd sit there and you'd say, guys, do you even comprehend what 100 megawatts is? Like, can you even fathom what it takes to give you 100 megawatts? And then they'd say something fantastic to you. So we'll use basic numbers. In a co-location space, let's say it costs $120 per kilowatt per month in rent. So these guys, because they have to do everything cheap, would say, and by the way, I want all 100 megawatts from you, and I want it for $50. And so because I can't help myself, I would start playing with these guys. I'd say, you know, it's kind of like I walk into a Lexus dealership and I'm like, man, that's an awesome car. How's $100? And they look at you and they're like, wow, that's awesome. You can leave. There's a door over there. But with these guys, they're unrelenting. They're like, okay, yeah, but I said $50. And I'm like, yeah, that's cool. It costs money. They don't care that it's our pleasure to lose money to deliver them a product. That was actually kind of how this whole thing worked. So it has a huge level of pertinence to this because you can't just go get what you want because you want it. Again, we'll go back to tapping on the phone. I want my wall. I want my wall. It's not going to be there. Facebook doesn't decide that they're going to be able to deliver you your wall right at that moment. Guess what you're not getting? You're not getting your wall. I found this hilarious. I'm not on any social media at all except for LinkedIn because you kind of have to be in our world. But so WhatsApp apparently had some major problems. No, Instagram. Instagram had some major problems the last couple of days. You know what was awesome? Everyone is tweeting about their problems on Instagram. I was like, that's fantastic. So I can't actually post the pictures of myself that no one really needs to actually see. So I'm going to tweet about how pissed off I am that I can't post them. Well, it goes back to accessibility. It goes back to resources. If the resources aren't there, you've got nothing. So it's important to talk about that hyperscale data centers are absolutely required, but power has to be delivered. Utilities have to actually do that. In case somebody hasn't noticed, utilities don't make a ton of money. PG&E. We are in their service area. You call them and you go, hey guys, we'd really like to buy more power from you. They're like, yeah, we can't deliver it to you. Do you have the power? Yeah, we can't pay for the infrastructure to get it to you. But you guys can. Can you subsidize us by paying $10 million so that we can then sell you our product? That's unfathomable. Go to the supermarket and they're going to actually charge you to go and get the tomato you want to buy. And then you buy the tomato. It makes no sense to me. So this is why there's some prohibitions to this actually working. If you've seen, hopefully you've seen the movie. It's not politically correct to say what it was said in there, but this would be big guy in a little coat. The big guy in a little coat. And if you remember Richard. So the cloud doesn't fit all for a variety of reasons. And some of these are known, some of these are unknown. The cloud is great for a myriad of things, but the cloud is also not, again, monolithic. So when we say, why can't I just use the cloud for everything? Well, there's certain applications that require real time, literally no latency, got to happen right now. Well, that would be the little jacket on our buddy over here. And you can see we're tearing, like this is all tragic. It's not going to actually work. There are many examples of companies that tried to throw everything they had into the cloud and then they realized, oh my goodness, I can't actually service all my stuff. The prevailing thought process is hybrid cloud. So some is mine, some is theirs. Well, that's the same representation of edge and the data center in the background. Give me some that does this, give me some that does that, and marry it all that together. This is, again, we'll go back to why one size is not everything that you're going to need. I love the look on his face. That's fantastic. This is going to give you the example of all of the parts and pieces that apply. So I do have to share is that my buddy is in New York, and he called me, and he said, my dad's angry because he can't call Uber. He said, I need a car, and I've been trying to call Uber, and Uber won't come. I thought that's awesome. If that's the microcosm, not just generationally, but everything else, that's fantastic. In order for you to call Uber or to get your, and now it's an autonomous car, how does that distribution work? So let's just think about that for a minute. My company hosts a couple of AI and autonomous car clients, specifically in Sunnyvale. They've let us know that a car on a given basis is going to generate around a petabyte of data per car per day. Now just quantify that and put that in your head when you start to think about how much data, even if you don't know what a petabyte is, just accept that that's big. So we'll just use that's big. You're like, wow, a petabyte, that's awesome. It's a petabyte? A petabyte's big. So a petabyte a car per day. Now this company, for example, the one that we host, is going to put in 30 cars. So that's 30 petabytes of data per day. That's massive. I'm going to store that at the micro edge? No, there's no way I could do that. We already established that. New York can't support that. Chicago can't support that. Atlanta can't support that. There's not enough space. It's too expensive. The edge, it doesn't go there. Regional data centers, that's going to be challenging. It's got to go somewhere in the back end. That's that hyperscale. So I've got to offload that someplace. But at the point in time that I'm accessing that data, where do I get it from? That's right at the site that I have to receive it. So you hear all this stuff about sensors. Sensors are grabbing data, grabbing data, grabbing data. That's got to be real time. So there's a resource that has to be close. There's then another resource that has to process that. So as we get to an increasing level of, it's an exponentiation of how much data, how much processing, it requires all this stuff. I don't think that's too complicated to just put that in your head and think about it. I've got to scale outward. The closer I am to the use case, the smaller it can be. The more processing, the more amount of what I have can be further away, but there's a relationship between all of them, and those all require different facilities. I had to just go back to this and debunk it again. So the edge is a fad. There's no way the edge is another fad. It can't be. We've created a world that requires this. So I talked to somebody the other day that was explaining to me that the edge was just something that was going to come and go. And I'll have examples of what come and go in a minute. It's impossible. By definition of our impatience, there's no way. The interesting part is because none of us actually have a real formal representation, and none is not a fair statement, most of us don't, in terms of how complicated this is to deliver, our expectations just continue to drive the other people that are responsible. So I live in Sacramento, California, which makes no sense to anybody other than there's a plane to get me to wherever I need to go. I don't own a data center there. 5G just rolled out. It's rolled out in 4 cities in the United States. I still don't understand this. They rolled it out in Sacramento, California. I guess we're special. The funny thing is they're reading the article about this guy, and he goes, and everything's fast, it's amazing. Well, he doesn't know that 5G is running on 4G and 3G infrastructure. So it's kind of fast. So the analogy would be putting a Ferrari engine in your Honda Accord. It's going to be faster than another Honda, but it's not a Ferrari. So we still have dependencies that we're not necessarily thinking of, and in order to enable everything that we're asking for, we've got to have some physical representation that doesn't exist today. So there's no way it's a fad. This should rattle everybody's brain a little bit. Connected devices. So when you think of what you're connected to, remember your refrigerator now talks to the internet. It does. Talk about Alexa, talk about Siri. I caught Alexa actually pinging our house. We've since disconnected Alexa because I knew this was going to happen. No one talked to Alexa in my house for a month. So Alexa started reaching out and wondering if anybody was there. So my son was like, Dad, what is that? And I said, I told you this was going to happen. And you could hear Alexa in the other house making noise. Why is Alexa making noise? Alexa needs information. Alexa needs data. You're connected. Alexa's using that, right? Your Fitbit's using something. All these things are being used. There's all this stuff that is requiring bandwidth. All these things are now adding. Every time, the wearables, everyone's going to buy a wearable. And you thought, does everybody really need this iWatch on their wrist? Well, once they made them look cool enough, everybody actually did. A lot of people go buy those. You remember, we're this guy. Except now it's designer. Like I have a Gucci, so I can see Gucci on the back while he's being disrespectful. So all these things here are showing you by what year and where everything is going. We haven't talked about the Internet of Things, the industrial Internet of Things. It's really simple. It's all the devices that need to talk to each other. Everything needs to correlate. Alexa needs a human interaction. But Alexa's also interested in if the TV's on and Alexa can hear the TV. That's material. You're wondering why all of a sudden on your Amazon account, you're starting to see ads that you're like, I didn't search for that. Oh, yes, you did. All of a sudden you had a random thought, or your TV had an advertisement for, and I used this last night, a Ronco rotisserie, and no one's bought one of those in 20 years. And now all of a sudden you're getting ads. You didn't even know that guy still existed. And now you're going to be making rotisserie chicken next week because someone started sending you ads. Well, how does all those things tie together? That's the Internet of Things, and that's tying all these pieces together. You go to school. It was fun. I think last year, my son, and he knew better than to make a demand. He goes, Dad, I'm the only sixth grader in the school that doesn't have a cell phone? So it's not possible. Oh, yeah. No, it's real. He's the only one. And so of course, we made him feel bad and didn't get him a cell phone. So all these kids, you got to punish your kids. So you then look at all these other kids, and it starts that young. I don't know about you guys. You go to a restaurant. What's the new babysitter? The new babysitter is awesome. So that everybody sits down and goes, hey, here, thank God, now we can talk to each other. And now the kid's sitting there like this. Or you're in the airport and there's a 1-year-old on a tablet somewhere. They're all connected. So this proliferation is just going to continue, but it's also the things that you don't even know about. Remember, we talked about devices that don't even have an interaction with you. They talk to each other. The industrial Internet of Things, what does that mean? That means that manufacturing companies have all of the parts and pieces inside of their plant that talk to each other to make themselves more efficient. So now extrapolate this, go back to the edge. If that's happening real time, what processes all that information? Well, it's got to be some form of a data center, right? That's an edge. All that data has to be collected and stored. Well, I want the most recent data, so that's got to be something that's more closely approximate but is cheaper that isn't the edge. But I then got to keep it forever so I can continue to iterate on it. That's another big data center. The industrial internet is driving things that we weren't even thinking about. Then this is just how you get that tomato from whoever was actually genetically engineering it in some fake greenhouse somewhere. Remember, that's where we're all going. So all these parts and pieces have to tie together. I wanted to mention 5G because 5G is part of this process, and you'll hear that 5G is going to drive the edge completely forward. Yes and no. Everybody familiar with small cell? Anyone ever heard of small cell? So if you've had any telecom experience, we've had these varying developments of how technology actually applies to our connectivity. Small cell is supposed to be essentially the next representation of how this is supposed to function, how we're supposed to connect. It's a major part of 5G. If you read anything about 5G, it's going to take over the world. You're going to get blazing fast internet speed. I almost feel like we should just pull up the horse and carriage and you should sell medicine out of the back like they did in the 1800s. Just take this tonic and you'll start growing hair. This is similar along those lines. Nothing takes over the world automatically. It can't happen that way. It requires infrastructure. 5G requires a whole bunch of stuff to be purchased and deployed. It then requires a strategy to actually put it in the right place. So about 4 years ago, I was working on a project to try to figure out how to actually help the cellular companies get better bar distribution, 5-bar distribution in major metropolitan cities. So one of these companies, remaining nameless, said to me, we want to put our devices on telephone poles and traffic light poles. And you've seen these. You know, we're used to cell towers. They want to put it on there. They said that it was costing them $5,000 in man-hour per telephone pole to negotiate the rights to put one device on one pole. Now do your math. How many telephone poles are in this town? How many telephone poles are in the next town? It doesn't scale. So this stuff is going to be huge, and the technological capabilities are phenomenal, but it's predicated upon infrastructure. All that data then has to be managed. So you can start to see the tiering. It's not to say it's not going to happen, but if my utility can't give my business more power for me to give them more money to buy their power, then who pays for all this stuff? We're not Europe. Europe has done a very good job of going and making sure that people are connected. We have a whole lot of people in the United States that might as well be on dial-up. Why? They're willing to pay for it, but they're not willing to pay for the infrastructure. So when you hear 5G taking over the world, it's coming, it'll be there, but think of the reference of how we actually have to get there. This was good for a couple of reasons. When we talk about the internet being fundamental, imagine if you didn't have it. And there's actually been some studies, like you take all the internet service away from people and watch what happens for an hour, and they actually start getting anxiety. And there's been some scientific studies showing, like, if you take some corporate executive, like idiot like me, and you say, okay, you can't have your phone now. Phone is away. You start fidgeting, you start moving, you're nervous. This is a requirement. This is water, this is power, this is everything to all of us. We can't function without it. The interesting thing in showing you this is, how do we enable that, and what have we tried to do? So, anyone seen the kiosks in New York? Anybody know what they're actually supposed to do? I mentioned this last night, and somebody goes, but what are they for? It's a hilarious comment. It's for accessing the internet. You can walk up to one of those. It's got a screen. You can actually go and surf the web. And the immediate question for most of us is, who the hell would do that? Well, the answer is, you're right, not many people. But they put these things all over New York because 4 years ago, this was going to be the way to deliver the internet to everybody. So it's a phase. It's not wrong. It's part of the process. Do we want fiber to every house? Interesting thought. Makes everything fast. But there's 5G. 5G is fantastic, but 5G has a limitation, like leaves. Seriously. So if there's leaves of a tree that are in the way of the 5G transmitter, you're not going to get your connection. They're working on that. But now imagine if there's something that's more dense than a leaf, like, I don't know, a building. So does that have more effectiveness now? Maybe. I don't know. But who pays for that? I mean, if you guys have ever had the inconvenience, they're doing it right now in my neighborhood. I've got some esteemed fiber carrier digging up my entire street, and these guys are fantastic. They'll coil up all of the conduit on your front lawn, as if that makes sense. Well, we're just going to make your internet faster, buddy. Yeah, but for the next 2 weeks while you've dug up my street, I can't drive down my block, and you're going to put all this in. It's a lot of stuff. When you start to conceptualize that, that's a lot. But you can't be antiquated like that. And yet at the same time, I want that. I mean, how ticked off are you when you're in somebody's office building and you can't connect? And we still do this, right? We're still cultured. You're standing next to the window. As if that makes a difference. Like, you got to know better than that. It's not the window. It's not the 5G where there's some distance limitation. It's that company doesn't offer you service in that building because they haven't built it in yet. How many buildings are there? It's not cheap. This stuff is expensive. So this brings us to our last one after I click a myriad of times. And it's who's responsible for this? So what does an edge deployment look like? So that's a data center at the base of a cell tower that's on the far end. And that's very logical. You need that. It makes a ton of sense. Put the compute and storage power right at the source. Well, again, we talked about it. It works for some of the deployments. Go try to do this in a major metropolitan city. Furthermore, try to go and deploy those at every single cell tower. I don't know about you, and I'm not knocking anybody in Iowa, but try to traverse all the cornfields in Iowa and put one of those in every single cornfield in Iowa, let alone talking to the guys that own those sites to try to negotiate that. I'll give you an anecdotal example. I built two data centers in Quincy, Washington. Quincy, Washington, other than now being known for a lot of data centers, was known for two things: potato farming and hay. So this is fantastic. So the economic development guy takes me out. He goes, Jason, the way this works is you got to go to the bar. That's easy. Okay, I like going to the bar. So we go to the bar, and I'm the only one who's not wearing Carhartt and isn't wearing overalls. And I was kind of dressed like this, except I really did it wrong. It was like a pink print shirt, so I absolutely didn't fit in. And he said, just talk to people. These guys own all this land. These are hay farmers, potato farmers. It'll be awesome. I said, I don't know what awesome is, but that's great. So everyone's staring at me because I'm the odd duck. So I finally stood up on my chair and I said, okay, guys, here's the deal. We know that I don't belong here. I know that I don't belong here. But I'm looking to buy some land. I'm going to build one of those big buildings that Microsoft built downtown because they were the only other one realistic at the time. If anyone wants to talk to me about your land, come on over. By the way, I'll buy the next 3 rounds of drinks. It's usually easy. But it's all a lot of PBR up there, so they were cheap dates. At any rate, so I'm sitting there, and this guy sidles up next to me. He looked like Yosemite Sam without the mustache. And he kind of elbows me. He's like, I can talk to you about some land. I said, that would be great. Have a seat. What would you like to drink? He goes, I just want to talk to you. He said, a lot of people have been looking at my land. I said, okay, well, what's it going to take to buy your land? He goes, a lot of money. And I sat there and went through this conversation. I said, well, can you tell me who else is trying to buy your, this is fantastic. Who else is trying to buy your land? He said, well, it's confidential, but it's a fruit company. Okay, we might be able to guess who that is. The thing is with this guy, even though that all he did was farm potatoes, it took us almost a year to negotiate a contract with him. We bought stuff in New York faster than that. So if we're going to deploy those in every cornfield, it's not as easy as you think. So is the edge then also a commercial office building? Well, it could be. If you have space that is proximate to people where people actually work in there, that could be a great location for an edge data center. But now what do you need to do? You need to go to a commercial real estate landlord who has never talked to anybody about computers and how data centers work. And by the way, we'll go back to the redundancy statement. I need to make sure that that little data center in that building doesn't go down. You know what commercial real estate buildings do at 5 o'clock every night? They shut off the air. Computers love that. Thermal runaway is fantastic for my processing power. How do you now explain to him, no, buddy, tell your facilities guy he's got to leave that one room on. We weren't built for that. So you got to negotiate that. So that's also a challenge to get there. Is now all the edge going to be sitting on a tower somewhere because my compute is so fantastic it fits in here? No, we're not there. We can make really small things really fast, but we talked about storage requires stuff. Remember, a petabyte. Let's just say a petabyte is that big. Just say it's that big. A petabyte, a car a day. 30 cars, I've got 30 of these every day. I think I just filled this room in 4 days. Doesn't fit there. So that means it's, what is it? Well, we don't know. It's all of these things. And it's an imperative for all of us to think about in our various professions how we enable this. So when I talk to the commercial real estate guys, I got to put things in their mindset that helps them understand why this is important. But the most important thing is how they collect revenue out of it. They just want to get paid. We want to get service. So it's how do you combine all those things together? And we're going to summarize here that what are the challenges to make the edge functional at scale the way we want? Growth. So if I build this module that's at the base of a cell tower, and then all of a sudden technology requires me to add more power, cooling, space, compute, and it was in the size of a box. Like I built a really pretty porta potty looking thing that has a bunch of computing equipment in it, and now all of a sudden I need more. What do? Add or daisy chain another porta potty? That doesn't really work. So we need to think about how do we scale, and that's not easy. People don't build things speculatively, so that's a challenge. Capacity. So it's not just power capacity, it's compute capacity. What happens if whatever, take your provider, makes a new device that can do double the amount, but it requires more power and has to go into the same space? How do I fix that? Who provides all this? Where does this come from? Who are the folks that are going to deliver this? How much does it cost and how fast can I deliver? And then who owns this and makes this happen? Who are the people that enables this? So these aren't questions to say that it's not going to happen, but this is all of the stuff that actually comes together, and it's this puzzle piece. Are we all going to share everything and make it all together? Are we going to all combine and do this? We can't. You can't share and make all of this something that we all use together. So for example, I have clients that are all AI clients. So I've got 4 AI clients, and if I went to them and said, hey guys, you guys all do AI. Can't you guys share all the same computers? They're going to throw me out of my own building. No, I need my own stuff. No, it's good. Just like put some of that crazy security on there, right? No, that's not how it works. So we have to think about things like regulation, who's going to deliver, how big it is, and how stuff intertwines. This requires a lot more infrastructure than we contemplated. It's not just going to be one happy, homogeneous space where we all go and hang out. So that's it. I probably bored you to death. I apologize if that's the case. It's a complicated topic. There is no one answer to this. The whole goal here was to show you all of this stuff and how all this comes together. And the thought processes are is that when you hear somebody say it's only going to be one thing, all I would challenge you to do is think about the reference of how all this actually applies. It's not just something more that's singular. Every click of this thing, in theory, is monitored, managed, and recorded. Somebody could monetize the data that you gather for how fast my thumb twitch is and sell me something that makes my thumb faster. And it's not illegitimate, right? So that all has reference. So thank you guys for listening.